Okay, great. Well, welcome everybody to Cloud Native Madison June meetup. We are excited to have our last, or not our last, but kind of last meetup before the break here. For those who haven't been attending too long, we typically take the months of July and January off, just with the early holiday during the first week. So we'll be getting back together in August. A little bit of cloud native news. Typically, we try to cover what's been going on in the community over the last month. To be honest, it was a pretty sleepy month for cloud native. Not a lot of new, project graduations or other kind of big moves. But I did want to highlight one thing, which is that the Cloud Native Foundation is now sponsoring a channel on Twitch, all centered around cloud native. So they're planning to launch this on June 7th, and to have 10 recurring both live and recorded shows, all centering around cloud native, covering topics from sort of cloud native and containers 101 to community focused shows, to also some shows that kind of are taking deep dives on various topics. So that's really cool. Another cool way to engage with the community and be able to learn about these things in a little bit more modern format maybe than just reading documentation and things like that. So yeah, we'll look to that, and hope that will be a great resource for the community. As I mentioned, our next meetup will be continuing to be online. It'll be August 5th at noon Central. We are very interested in anybody who would be curious to give a talk. And then, as Kurt mentioned earlier, as we get into the fall and, more companies are opening up, kind of on-premise events, we're definitely going to be looking to take the meetup back online, or excuse me, back offline, and maybe still maintaining, some live streaming capabilities, which we've attempted in the past. But, I think we've gotten some great participation from folks who otherwise wouldn't be able to join us on premises for our meetups. And so we'll be looking for ways to maintain that going forward. With that, I just want to welcome today's speaker, Jon Jenkins, who's a systems engineer at Integral. Jon answered our call to action when we kind of put out to the community that we'd really like somebody to give a talk on Flux, which is, an up and coming project within the cloud native ecosystem. And Jon graciously volunteered to learn Flux and give a talk on it. So with no further ado, this is Jon's talk, Exploring Continuous Delivery with Flux and the GitOps Toolkit. Take it away, Jon.
Yeah, thank you very much, Brandon. I want to say that I appreciate, the reiteration that I didn't know anything about this before the last talk. So we're kind of exploring together here. And this has been a really fun little project to work on, this continuous delivery. Super easy to set up, but then obviously, like a lot of projects, kind of gets progressively more in the weeds and difficult. So I will kind of share with you what I've learned over the past, little while that I've played with this. Oh, I see I have the wrong date down here. In any case, this is a continuous delivery with Flux, and everyone can see this. Yep. Okay. Great. So for today's resources, I did put some repositories within my GitHub project around this. This slide deck is in there under the projects, and then some deployment examples, a simple Go web server that I'll be using in today's talk with some actions, basically to build and push to a registry, and then the registry itself. So if you want to kind of dive into what I've done, you're more than welcome. So FluxCD, verbatim, this is a tool for keeping Kubernetes clusters in sync with sources of configuration. So basically, deployment as code, that we've talked about. That's part of the CI/CD mantra, right? You want to be able to reference who made what change, when, rollback, commit, put a lot of the GitOps around what your code looks like, including the deployment. So that's what Flux really is. It's a tool to watch Git repositories and then sync up Kubernetes based on what it finds. Oh, and I forgot to mention, if anyone has any questions, of course, please post them. And I'm very happy with interruptions if that works better. If you just want to get a quick question, please go ahead. But right, so we're able to set up a Git repository that houses the Flux configuration. and then sync that down to Kubernetes and tell it basically how, which other repositories we want it to watch and how it's going to apply those to our Kubernetes install. So covered today is just a general overview, kind of a comparison to, maybe other tools out there. We have a couple of examples, a really simple web server that has a continuous deployment. So, if you submit code, it's going to go ahead and apply that to the Kubernetes cluster. And then the example 2 is a multi-tenancy deployment. And this will be kind of a really simulated multi-tenancy because we're only going to be using one cluster for this. But I'll show you the code that kind of would jumpstart you into applying this to multiple clusters. A quick explanation of Flux examples not covered in today's talk and why they're not. And then a comparison of some existing projects, because there are some other projects that are doing something very similar to this. So just kind of a little bit brief history. I'm sure most people here are familiar with Helm. And Helm is a great way to deploy software to Kubernetes. One of the, it consists of a client calling an API and telling it, I want this chart, I want these values, apply it. It takes care of that, and based on whether or not that deployment becomes ready, it's either deployed or it's rolled back or it fails out. But after that, after it's done that good work, it's really done until a client calls the API again. It's not going to update it. It becomes out of sync. You could delete the deployment, and it's not going to put it back in place. So that's where Flux comes in. And so Flux is kind of, really utilizes Helm and is a wrapper for it. Basically, will, like I mentioned, watch Git repositories, pull them on an interval, and then attempt to reconcile them. And then on the Kubernetes side, does the same thing. It pulls Helm, asks, what state it is in, and then tries to reconcile it. And it is based on their own set of CRDs. One big note, and I'll probably mention this later, but Flux recently went through a version upgrade. They went from version 1 to version 2, and they made some substantial changes to their CRDs. So there's really no compatibility between the 1 and 2. I did find myself in a bit of a pickle at some points because I was writing Flux 1 code and trying to apply it and then wondering what was happening. So it's one thing to really watch out for. I think they have a little bit of work to do with their documentation, kind of really buttoning that up yet. But yeah, so Flux has basically custom resources that you'll be modifying that have specific fields that will instruct Flux how you want to upgrade or reconcile to Helm. So there's quite a few components of Flux. You'll notice a lot of these end in CRD. That's just the way that these are controlled. So it gives you a lot of options as far as source controllers. It can be a Git repository, Helm repository, Helm chart, and a bucket. The custom controller customization, that's kind of like that's the guts of Flux. And that basically says, hey, I have something custom and it's just for Flux. And Flux has defined all these inputs based on it. So that's really where you get a lot of your hooks into to other resources. Then there's some notification controllers. I'm not going to touch on those too much this time, but they are there. You can shoot out alerts, to Slack. And then there's an image automation controller. And I played around with this a little bit and found that this was one of the things that they were changing very quickly right away. In fact, my Flux controller didn't like one of the CRDs that I submitted, but it passed some automatic linting that was already set up for Flux. So there's just a slight disconnect there. So I kind of set that one off to the side and thought, it's probably just not for today. So my first example is a super simple web server. I'm going to be using Minikube as my Kubernetes environment. There will be 2 namespaces, the Flux system, and this will control, house all the Flux deployments. And then in apps, actually it's going to be slightly different. It's going to be called a staging namespace, but it's going to house that Go web server. So essentially, we're going to have 3 components, 2 repositories and a registry. The main registry for the Flux Go web server, that's going to contain all the guts of what Flux knows that it's going to do. And that Flux, that repository will have a basically knowledge of this private repository for the Go web server. In order to do that, we're going to have to provide Flux with some secrets, and I'll go over that later. But essentially what we're going to do is we're going to deploy first this Go web server using Flux. That's going to pull from the registry. And then we're going to make a simple change to this Go web server. We have some GitHub actions that will build it, push it, and then update the deployment. And we'll see kind of how that whole interaction happens, and that just based on committing code to Git, we're able to see our deployment update. All right. So I'm going to hop over to a command terminal here. Looks like hopefully that's legible, but essentially I have Minikube running with almost nothing going on inside of it. And I have this this Flux Go web server project. Again, this is in my personal GitHub. And what I have is just 2 directories, clusters, Minikube. So that just corresponds directly to this Minikube cluster. And then I have a couple of scripts. And I'll go over these scripts one by one. Essentially, we can bootstrap Flux with this command, specifying that we're going to be pointing at GitHub. The owner is going to be me. I have this as an environment variable. And the interval is how often we want Flux to pull on this, repository. So, normally you'd probably set this something at like hours. But, for today's demo, I want to keep it pretty short so they're able to see those changes and we don't have to wait around a lot. The repository is this Flux Go web server, which obviously corresponds to where we're at. So basically pointing at itself. We're going to be updating the main branch. And then the path that we will basically associating this, this deployment as is under cluster Minikube, right? So essentially you could kind of call this multiple times and point it at different clusters, like if you had a staging cluster, a production cluster, you could call this multiple times with different possibly branches, but we're just doing once right now with Minikube. So what's going to happen is I'm going to issue this, and it is going to go and basically hook right into that Minikube cluster and then update the deployment for Flux. And then it's going to actually update this repository. So we'll see that happen. So here it is kind of booting up. And here it is syncing the manifests to this repo. And then it's going to be waiting until it's fully reconciled in order to do anything else. Okay, if you notice, I did have a git pull here at the end of this script, which pulled down a whole bunch of components from this Flux system. So I could take a look at this, but basically, because Flux works on CRDs, it's set all of these CRDs for you and put them into repo. So next time it goes to pull, it knows exactly where it started from, right? So this is a kind of a standard setup for Flux, is that they will have a customization YAML which is their generic customization kind. And often they'll reference resources. So in this instance, it's these two YAML files. So it looks at this customization first. It sees that I need these two resources, and then it makes sure that these are synced up. Right, and then we can see our intervals, our URLs, and then the path. Right, so those are the ones that we specified on the command line, but that we now have in YAML. So as I mentioned, we're going to be using a private Git repo, which means that Flux needs to know that GitHub token. In order to have that token, I could inject it directly as a secret within my cluster. But because we kind of opt for keeping everything in code, Flux has a way to do that securely, right? So we don't want to just put secrets into GitHub repos. There's many different ways to handle it. But in this instance, we're going to be using a resource called sealed secrets. And basically what's going to happen is Flux is going to install a Helm repo and deploy for sealed secrets. And that's within here. And then what it's going to do is once that is up and running, then we can pull out a public key and then use this public key in order to create a secret. So something like this, right? Within the Flux namespace, we're going to create a secret called GitHub auth, and it's going to use my username and my password, my token from my environment variables. It's going to output that into a YAML file that's stored locally. And then we're going to run this kubectl. It's taking a format YAML using this public sealed key that I mentioned that we're going to pull out with the input of the the secret, the generic secret from kubectl. And we're going to paste that into clusters minikube GitHub auth sealed. So that becomes part of our deployment to minikube. After that, we're going to just remove that secret. And then we're going to add to the GitHub the sealed secret. Remember, that's a public secret. So we don't care that it's in a repo, and then add everything under clusters. So if we actually look at secrets here, and we're going to go look for GitHub, we can see if there's nothing there right now. Let's go back to PO. So now we can see that within the namespace, Flux system is this new sealed secret pod, which is going to take care of that customized secret, basically, that we're uploading. So this is what's saved in our Git repo. This is a way to, like I mentioned, to save a secret in your Git repo without it, without fear of it being compromised, right? This is not a base 64 password. It's encrypted with a very specific key that was set up by sealed secrets. So we can feel confident about that being in place. So if we watch our sources from Flux, we should be able to see the secret come down. Let's see if that is there. Okay, so there it is, right? What we were looking for. It's got a username and password. So this will allow us to basically hook into our next test, which is this web server deploy. And I guess one thing I'd like to go back to is that we created these releases using this Flux command, you can do it two ways. You can either submit YAML to the repo and then have Flux go and pick it up and then apply it, or you can apply it directly. The problem with applying it directly is that it doesn't automatically sync back to your repo. So if you wanted to export it, you could call a command like this. Then you could take this YAML file and basically, insert it into your cluster's Minikube into a file. I'm not going to do that right now. I'm just kind of showing you a couple different ways, to handle this. So that's why this web server deploy, I'm just doing a cat into a YAML file and specifying that there's going to be a namespace staging that I'm setting up a Git repository within the Flux system namespace. You could put it in the staging namespace, but we are putting this Git repository in the Flux system. I want to pull it every 30 seconds. I only want to look at branch staging because I'm trying to associate the staging namespace with the staging branch of the Go web server as if we were, this was a complete cluster on its own, but it's not. So the URL of where this code is, and then the secret ref for this URL, right? So that's that GitHub auth. And then the last component is this customization. So here's another one of those like kind of really generic Flux CRDs. And it's basically telling, again, a poll of 30 seconds. For this repository that's called Go web server, right, that we set up here, look in path customize and apply whatever you find in there. So essentially, we are going to stick a whole bunch of YAML within this customized directory of our Go web server. And I'll actually, I think I'll pull that up now so it's a little bit clearer. So this is the Go web server. We're on the staging branch. And here's that customized directory, right? So within it, we have a deployment, super simple deployment. Just saying, here's my image, Go web server. It's got this tag of staging. There's an HPA. Here's that customization file that I mentioned that has the resources, apply this HPA deployment and service. And sorry about that. And then a service to go with it, right? So that's within that customize directory. So we'll apply that right now. And what this will do is it's going to spit this out to a file. And then we're going to basically apply this kind of like the opposite way. For the sealed secret, we applied it directly using that command. But for this one, we're just going to add this YAML to our repository, commit it, and then push it. And we should be able to see that come down. So what I'll do actually is I'm going to watch the tail of our customization log. And I'm going to go back to our pods. So if I call that, so it wrote that YAML file, it pushed it. And we should see that we saw this update, the main. So it's saying, hey, I got a new directive basically to apply. And here it is, staging namespace, Go web server, right? So it's quite that easy. If I look at what tag this image is at, I should, oops, this is the wrong one. This should match up with what's in my deployment here, 417, right? And so if I go to this, if I port forward, right, we can see that it's a staging branch. So let's say we're going to make a really nominal change. Say I have been updated. We're using Git workflows, specifically actions. And I'll just run through this really quick. It's not a huge part of this demo, but essentially we're going to generate a build ID based on the branch. So this will have a staging, a subset of the SHA, and then a timestamp on the end. It'll check out the repo. It'll build this web app, and then basically it pushes using this build ID. At the end, I do have this update manifest. So this customize update deployment runs with an argument of this new build ID, right? And then we add and commit the new deployment. So basically what I'm saying is build this new package with this name. Okay, now you have this name, go and run this shell command to update the deployment in this branch. So if we look at this update deployment, super simple. Basically within customize deployment.yaml, it's going to update that tag to be the newest version. So let's see that we have a change. So we pushed it. Here are the actions for this web server. So here we see the commit. This takes just like a minute or so to actually complete. Or maybe a touch longer. Okay, so it looks like that committed. So now we're going to wait for this to basically come down on this side. Okay, see the change that happened right here? So it found a new commit to the staging, and it's already installing that new version. So we can ensure that this image is what we would expect. We would get pull show. So our new one is, ends in 576. Looks like that's what's been deployed. So that's great. Then we can connect and just verify. So there we are. So basically, super simple example of how to utilize Fuse to basically update Kubernetes, right? So just one app. A lot of people aren't going to do this, but it was a good way to kind of dip our toes into what's going on here. So what I'm going to do now is issue this teardown, and basically it's a Flux uninstall. And then I'm just going to do some general cleanup on my sealed secrets, because that's going to be no longer valid once I delete Flux. And I'm going to clear out essentially all these YAML files that I have within Minikube, because again, they're no longer going to be valid. So. We see everything kind of terminating. And we should be clean at this point. So I'm going to run back to the slide deck. So that was that example. So my next one, this is going to be a little bit larger, and I'll try to speed it up because I know that we're a good way through already. But around the same idea, but this is going to be multi-tenant. So the idea that Flux is going to be able to watch multiple contexts. You know, if you had an integration, a staging, and then a production environment, you know, we want to be able to kind of format our Flux install so that it handles all of these environments in a very, you know, similar way using inheritance. So that's what we're going to do here. So the repository that we're using here is the Flux multi-tenancy. There's going to be a couple of major directories. The clusters are going to contain all the Flux configurations, as you saw before with the Minikube setup. Infrastructure, it's going to handle or hold common infra tools. You know, we're going to have possibly admission controllers, other CRDs, and cluster-wide policies. And then tenants. So this is really, if you want to think of this as like where you'd have your developers set up. So basically you're defining, okay, these are my developers. This is what, you know, they can apply. And these are the Git repositories that they belong to. So that's what we're referencing here with this dev team, as just as if, you know, this is my my code of like how I want it deployed to each environment. And then obviously we're still using that same registry. All right, so let me pull up this file. Okay, so in this example, we're going to associate staging with Minikube. So that's basically the only kind of leap of faith that I'm asking to make here is that before we had named this Minikube, now we're going to name it staging. It's really the same thing. So our staging environment has two files. One is this tenants, and again, generic customization. We're going to wait on this depends on for just a little bit, but mention that it is a Git repository, and it's associated with this path, and these paths are to this repository. So it's tenant staging, and we'll go over that later. It's right down here. So that's the staging environment. Again, I'm only doing one environment. You could have, you know, production or integration or anything else here. What this depends on, this Governo policies, is located with this in this infrastructure YAML. So Governo, if you're not familiar, is basically an OPA. You know, Kurt gave a talk on Styro. This is just slightly different. This came with the example, so it's a little bit easier to set up as far as YAML goes. But otherwise, you can use basically any OPA you want to. So what's going to happen here is that it's going to set up a reference an infrastructure Governo directory, which is right here, which basically is a link to a bunch of CRDs. I'm not going to visit it right now, but Essentially, it's all the ways that Governo is set up, right? It's also referencing policies. So if we hop over to policies, again, here's that customization, include this resource in a super simple policy. And our policy for right now excludes the Flux system namespace. It's going to match on resource kinds of customization in Helm release. And it's going to say, if you do not have a service name defined, then you can't deploy. So relatively simple. So those are the first two directory structures. Next, we have kind of where we put our teams, right? So we have a base and a staging. And I'll kind of explain why that's important later. But under our dev team base, here's our customization. We're going to have an RBAC and a sync. And of course, if we had multiple contexts to deploy this to, we'd expect that this base one would apply to all of them, right? So that's kind of how we write them. So we're going to define a service account for everywhere that dev team goes, and then we're going to use it in a role binding and basically tell them that they have cluster admin within the app's namespace. And at the same time, we are going to set up a Git repository for them. So imagine this is their team repository. We're specifying the branch main. And then we are setting a customization for that team. And we actually have to hop over to the staging to really make that. I'm going to pull this up in the secondary here. This staging customization, notice, has a resource of that base dev team. So it's going to pull everything from there, and then it's going to merge this patch. And so this patch right here applies to this section here. And what it's going to do is add on a spec saying only pay attention for the staging environment for the staging path, right? So basically within the dev team's repo, they're going to have a staging directory. That's where we're going to pull our information. Okay. I think I'll try to pull up the dev team now. Give a quick overview on that. Okay, right. So the dev team's setup, relatively simple, but it's got a base and a staging. So you already understand that they have a similar hierarchy here. Again, we're going to reference the base, and we're going to merge in values that are specific to staging. So that's where we're going to define this specific image that we're using. So before we were keeping that directly with a deployment. Now we can really kind of separate that out per environment, right, and have the teams kind of dictate what's going into each environment. So we have Helm release and repository. And these are hopefully relatively straightforward. One thing I didn't mention before, and I apologize, Flux really operates on this version along with the interval. So you specify a version for the chart that you want. And how this becomes powerful is that for something like a staging or integration environment, maybe you always want to have the latest version of a Helm chart so that that when it breaks. And then maybe for production, you only want to have things that are tagged with stable. So this is where you would really do this. And this is how Flux will basically go out, look for those tags of those Helm charts or anything else that you're really utilizing, and then pull those back down if it sees an update, right? So it's going to try to apply whatever latest one that you've specified for that work. Let's see. So I am using a Helm repo that I set up. Unfortunately, we're not going to be able to kind of like go through updating the chart. We just don't have time. But it is part of the config if you wanted to try it out yourself. So we'll kind of get down to it here, and we'll bootstrap this environment. So really quite the same thing. We're going to see a new commit to this staging environment. And here it is, finding that latest tag. So it does match up with this tag. Here it is installing Caverno. Remember that that was depended on by the infrastructure. So that's going to be set up absolutely first. Let's actually watch some logs here. So once it's got this Caverno all the way set up, we are looking for it to install our web server. Okay, here's the tmaps is not ready. It's going to try to sync it, and bang, I get a denial saying that the Helm release for the AppsGo web server was blocked due to a policy, right? So service account name was not set. So if I bring up my Teams Helm release, I can see I had commented this out. So if I add it back in, I should here see a update to the repo pop up. Oh, there it is. And now it passes because it has a service account name and it is applied. So at a high level, that's kind of one of the ways that you can deploy using Flux. There's obviously a ton more to talk about, but I'm kind of running out of time here, so I'll kind of go back to the slide deck. So several other uses within Flux that I didn't get a chance to talk about. Continuous image update, and this is, I did touch on this briefly, but essentially it's going to watch a registry and then update your deployment continually whenever it sees a new tag based on a regex that you can define, or just based on a semver that again you define. This one I think was in flight recently. I mentioned that there was some breaking changes between a V1 and V2, and then it also happened again in their V2 to like alpha stage. There were some breaking changes, so it just it got a bit problematic for me to demo today. You can definitely do red, blue, green, or canary progressive delivery using Flux. There are several examples of that. And then obviously we're talking a lot about Kubernetes. There's Flux on Azure as well. And then I was going to demo some Flux notifications to Slack. Super easy to integrate, but they're there. So just real quick, touching on similar projects, Argo, very, very similar to FluxCD. It's going to have a set of custom resources. It's still going to run in a Kubernetes namespace within your cluster, and it's basically a new native Helm. One thing I will pop back and show you. So we can see that because Flux uses Helm, we can see this installed. And if we were to do something like Helm delete the web server, you can see that it's uninstalled and boop, it popped it back up again right in here, right? So if we list it, and once it's up, it should list it. So there it is, right? So using Helm natively, in contrast to something like Harness, which basically uses Helm only as a templating system and then applies their customized additions on top of that. So that's one of the big things that I noticed with Harness is that if you really want to kind of dig in and see what's going on within there, you just can't use Helm. You can't expect that to help you out. Both Harness and Argo have a UI. Harness is far and away more kind of intricate. But I guess the big comparison is that Harness runs an agent within your Kubernetes that basically takes input from the UI, the web UI, and then directs it to that agent. Whereas Argo and Flux are really kind of contained. All those configurations are within your project. So, there's no worries of like your passwords or something being out on a completely different system. All right, I think that I got through that as quickly as I possibly could while leaving some time for questions. Can I answer any questions, or does anyone have anything?
John, first I want to congratulate you on a flawless live demo. I don't know what gods you sacrificed to this morning, but that was extremely well done. No hiccups whatsoever. We do have some questions in the general chat channel here. So first, Tanvir asks, what problems did you all face that brought you into using Flux? I'll give a little bit extra context there to start off. So we actually just put out a general call to the community to see who might be interested in kind of learning and presenting on Flux. So this isn't something that's actively used in production. This was more kind of exploratory around just wanting to get more familiar with an up-and-coming project in the cloud native space. But maybe rephrase it a little bit there for John. Like, what advantages do you see along this approach as opposed to something like Jenkins, which I know those of us who have worked together at Integral in the past are all familiar with, and maybe some other tools like that.
Yeah. So in my diagram, I put a Jenkins icon in front of that Helm deploy as saying like, Jenkins is perfectly capable of calling that Helm API or calling whatever you do. But after that process is done and that Jenkins job is done, it's not waking back up, or you have to set a cron if you want it to like be in sync. So there's all these extra steps. So I think what Flux really handles is that how do I know that what I have in my repository that I know is versioned and has all these gates in front of it, commit or whatever else, and linting, and all these other really cool things. How do I know that that's what is reflected in my deployment? And so that's really the glue that that Flux provides, because it says, you set up basically what you want and we'll make it so.
Yeah, it seemed to me also like one advantage I see based on what you presented there is everything's kind of feels Kubernetes native. You're configuring stuff through Kubernetes YAML manifests as opposed to with Jenkins, say, scripting it out in Groovy, or maybe you're doing it from something like GitHub Actions and you're kind of scripting it out using Bash or stuff like that. It seems like the fewer tool sets and kind of things developers have to learn how to manage, the better. And this seems like a very Kubernetes native solution.
Absolutely. Yeah, I didn't get to mention that, but yeah, thank you for bringing that up. Is that, yeah, kind of lessening the toil for languages, right? I think that, YAML, I'm sure everyone's got an opinion on it, but it's relatively easy to read. And once you kind of get people in the groove of it, like this is all we're going to do, and you don't have to go out and run out and say, oh, my Jenkins deploy filled failed. Why is that? Now I have to, I haven't looked at this Groovy code in, half a year. Oh boy. So yeah, it definitely lessens the playing field there. And then one from Aura here. Yeah, so I think a lot of based on what you want to do, are your tests, something that you run while your pod is coming up or while it's in place? I mentioned, those links that, they have canary deployments. So you can certainly set up something where, Istio is basically going to route, part of your traffic, based on a header or whatever else, from your automated tests that Flux knows about to say, yes, this is good. It passes my tests. Otherwise we're talking about tests that might be on the back end for, building that image and making sure that image is fine. But, if that image never really gets built or released to the registry, then Flux just won't install it. Let's see, if something deployed after push needs to be rolled back, what does that look like? What does a git revert look like? It's essentially it. Very easy to basically say, and I had to do it several times this morning as far as the demo not having problems. I skipped a few meetings because for some problems this morning. But yeah, I seriously was having a problem. I did a git revert and the cluster responded and basically realigned itself to how I had it set up before. And things were great.
Cool. Any other?
I have to agree that the presentation was excellent today. How long? Because we did, do a call out for you to learn this, so you came into this knowing nothing. But to get that basic example up and running, how long do you think it took you to do that?
An hour less. What I fought with, and I shared this with Kurt, was that I really wanted to showcase this multi-tenancy. And so I was trying to shoehorn utilizing different namespaces kind of as those different tenancies. And basically to do that, I would have to have a Flux namespace per, pretend cluster. And if you can imagine spinning up all these pods on Minikube and then trying to keep track of all that, I just didn't have the resources for it. So that's why I kind of went the fake route. So the only thing that took me long at all was trying to really shoehorn it into something that maybe wasn't meant to do in order to provide a demo. Other than that, if you go to their GitHub and you look at their multi-tenancy, you can pull that down. Very similar to what I have. I took out a few things, but really, you can get started and go right away. It's quite simple.
Cool, great.
Any other questions from the attendees before we wrap up? All right, well, with that, again, we really want to thank you, Jon. There in a short timeline, learning something totally new, and having a flawless live demo. That's batting 1,000 on this one. Really appreciate it. So I think we'll repeat this pattern. If you're interested in potentially taking on a topic, an interesting project from Cloud Native and kind of kicking the tires on it and giving a presentation similar to what Jon here did today, we'd love to hear from you. I think this is, we love having outside people come in and give talks, but it's great when we have members of our own community kind of getting engaged as we had here with Jon today. So thank you very much. Have an excellent next 2 months. Enjoy your summer, and we'll see you back in August.